Good morning, students. In the previous lecture, we are discussing with speed and velocity. So, speed is a scalar quantity and velocity is a vector quantity. Okay? Now, average velocity. The ratio of total displacement to total time taken is called average velocity. Okay, that is average velocity equal to total displacement is divided by total time taken. Okay, average velocity can be obtained by taking average. This is another method by taking average of different velocities. If a body is moving with different velocities, then we can find the average velocity by taking the average of velocities. For example, there are two velocities u and v. Then we get the average velocity by taking the average of these two velocities. Okay? Then uniform velocity or constant velocity. If a body is moving with constant velocity, then it has travel equal displacement in equal interval of time. Okay? This means if a body has uniform velocity, then it travels equal displacement in equal interval of time. Okay? Keep in mind that velocity can be changed in two ways. First, by changing speed. If the speed changes, then velocity also changes. Or by changing the direction of motion, velocity can change. Now, non-uniform velocity. If a body has non-uniform velocity, then it travels unequal displacement in equal interval of time. Okay? Yes. Speed and velocity are not always equal in magnitude. They are equal when the body or when we are traveling in a straight line, along a straight line. Okay? One another topic is acceleration. What is acceleration? Suppose you are changing the velocity of your vehicle, means of your car, of your bike, of your scooty, then change in velocity per unit time is called acceleration. Okay? Acceleration is equal to change in velocity upon time taken. Then we get the formula. Acceleration is represented by A. Change in velocity is v minus u. Here v is final velocity and u is initial velocity and t is the time taken. Then we get the acceleration A is equal to v minus u upon t. SI unit of acceleration is meter per second square. It is obtained by this meter per second upon second. For velocity, meter per second. For time, second. So we get meter per second square. Okay? The direction of acceleration is the direction of velocity. Means acceleration is in the direction of velocity and velocity is in the direction of displacement. Okay, so all three quantities are vector quantities, and the direction of acceleration is the direction of velocity, and the direction of velocity is the direction of displacement. Okay, note, if a body is moving with constant velocity, means velocity does not change, then acceleration is equal to 0. Okay, if a car is moving with constant velocity, then it is not accelerated, its acceleration is equal to 0. Okay, now we are talking about uniform acceleration. What is uniform acceleration? Means if a body has uniform acceleration, then it travels along a straight line, first thing, and its velocity increases in equal amount in equal interval of time. The first thing for uniform acceleration is the body is traveling along a straight line and the velocity increases in equal amount in equal interval of time. Okay. Now, non-uniform acceleration, simple. In non-uniform acceleration, the velocity increases in a different amount in equal interval of time. Okay. When we draw a graph for uniform acceleration, then we get a straight line. We get a straight line. Okay. When this is for non-uniform acceleration, then we get a curved line. Okay. So, in case of uniform, we get a straight line. In case of non-uniform, we get a curved line. Okay. Acceleration can be positive, 0 and negative. Means there are three types of acceleration. Positive acceleration, if the velocity of your car, if the velocity of vehicle increases, then acceleration is positive. As we know that A is equal to V minus U upon T, if we put V greater than U, then A is positive. If the final velocity increases, then the acceleration is positive. Okay? For zero acceleration, the body is moving with constant velocity, then acceleration is 0. Means there is no change in velocity. The body is moving with constant velocity. For we have A is equal to V minus U upon T. By V is equal to U is equal to constant, we get A is equal to 0. Okay. Negative acceleration or retardation. Retardation is also known as negative acceleration. What is negative acceleration? If the velocity decreases. If the velocity decreases, then acceleration is negative. Okay? Yes. We know that A is equal to V minus U upon T. If we put V less than U, then A is negative. Means if the final velocity of vehicle is less than the initial velocity. For example, if a car is moving and we apply the brakes, then final velocity decreases. It is lesser than initial velocity. Then this is the example of negative acceleration. Okay. Now some graphical representation of motion. As we know that for uniform motion we get a straight line, and for non-uniform motion we have a curved line. Okay. Now some other graphs are there. One is distance time graph for an object at rest. If an object at rest, then distance time graph is a straight line parallel to time axis. Okay. Another velocity time graph for a body moving with constant velocity or uniform velocity. Then velocity time graph is a straight line parallel to time axis. Okay. For negative acceleration we have the negative slope. So velocity time graph is with negative slope for negative acceleration.